Hi, my name is Arpit. In this video, I will be demonstrating week 6 of our electronics lab. This experiment is all about developing and testing voltage regulator using Zener diode. In this experiment, there are two parts. Part 1, I have to demonstrate in LT-SPICE software. Part 2, I have to demonstrate in physical. This is my official ID. Let's proceed with the experiment. So this is part 1 of this experiment. In this experiment I have to design a voltage regulator using 250 ohm resistor and as a load resistor from 10k to 100 ohm, and I am using 3.6 volt breakdown voltage in forward wise. So this is the diagram of this voltage regulator, and I am giving a 3.8 to 4.8 square wave using this pulse feature of this LT-SPICE, and this is a 250 ohm resistor in series with the diode that protect the diode, and this is the load resistor RL, and as you can see, this is the output wave that I am giving to the Zener diode, and as you can see, when the resistor value is high, the voltage across RL is low. When the RL value is low, the voltage across RL is high, and as you can see, this cannot break down to the 3.6 volt because the forward breakdown voltage of this Zener diode is 3.6 volt. So that's why the load resistor can't go above 3.6 volt. And let's jump to the next part of this experiment. This is part 0.7 of this part 1 experiment. In this experiment, the circuit is same, just in the minimal changes. I have added one Zener diode in the series, and now the both Zener diode has breakdown voltage is 3.6 volt. So if I added it, that is 7 point. Now the breakdown voltage of this, that is 7.2, and the series resistor, that is 250 ohm, and the RL is variable from 100 ohm to 10 kilo ohm. So as you can see, this is the output wave of this circuit, and as you can see, in this the output wave is same. As you can see, the RL is small, the voltage is high. If the RL is high, the voltage is low. In this case, as you can see, the breakdown voltage of this voltage regulator is 7.2. So that's why this RL wave goes across it crosses 3.6 volt, and it goes up to 4.2 or something, but it can't cross the voltage I am giving. If I increase the voltage that I am giving, so let's say I set to the 8 point something, and let's generate the waves, and now you can see I have increases the voltage from 3.8 to 8.8, and the waveform that I am giving is 3.8 to 8.8, and now as you can see, the RL voltage it can't cross 7.2 because in the series, as you can see, there are two diodes, and both forward breakdown voltage is 3.6 volt. So this can't cross this limit of the breakdown voltage, that is 7.2. So yeah, this is the 0.7. Let's jump to the next point. This is 0.8. Just I replaced the series resistor that protecting the diode. I replaced to the 500 ohm, and all the values are same. Zener diode breakdown voltage is 3.6 volt, and as you can see, the triangular wave I am giving, that is 3.8 to 4.8, and the output of this load resistor, as you can see, it can't break out the 3.6 volt because it same as the 0.6, because the breakdown voltage of this Zener diode is 3.6 volt. So the RL, if I increase the RL, it can't break out the 3.6 volt. And you can see it when I added a series resistor of 250 ohm. As you can see, the voltage is something around 1.2 or something. When I added 500 ohm resistor, the voltage is less than 1.8 or something. So this is voltage regulator with 500 ohm in the series. Now this circuit is same as it is. In this experiment, I am just adding one Zener diode in the series, that is the breakdown voltage same as it is 3.6 volt, and the output triangular waveform I am giving something around 3.8 to 9.8. If I added the breakdown voltage, so it's give me a 7.2 or something. And as you can see, this is similar to when I added a 250 ohm resistor, and similar to the 250 ohm resistor. And as you can see, it can't break out 7.2 voltage because the breakdown voltage of this both Zener diode is 7.2. And you can see the RL value, when I increase the RL, the voltage is decreases. When I decrease the RL, the voltage increases. So this is another point of this experiment. So this is the last point of this experiment in part 1. I am giving a triangular wave that is from 0.7 to 7.8 or something, and the breakdown voltage is same. I just replace RL with 1 kilo ohm resistor. So the output of this, as you can see, it is similar. Just when I using a variable resistor, I am getting too many waves. Now you can see this is the RL, and the blue color waveform is voltage across RL, and it can't break out 3.6. So that is the LT spice simulation of this experiment. Let's jump to the physical experiment. So this is part 2 of this experiment. So as you can see in the circuit, I connected accordingly in the physical. So let's jump to the physical circuit. So this is 220 ohm resistor I am using in the series with a diode, because I don't have 250 ohm resistor, so I am using 220 ohm. This is a 3.6 volt breakdown Zener diode, and across parallelly I use a RL resistor. So I don't have a way to connect any RL, so I am using a trim pot as a RL. So when I rotate the knob it decreases and increases. So this is a channel B, that is measure the waveform, and this is green wire channel A, that is giving a triangular wave, and this is the ground. So as you can see in the pixel pulse, I am giving a 2.8 volt to 4.8 volt triangular wave, that is 100 hertz, and at the output I am giving right now, it is 0, because the parallel RL register, the value is very high, approx something around 10k. So that's why the value is 0. When I rotate the knob and decrease the value of this resistor, as you can see in the pixel pulse, the waveform is giving output as a triangular form. And now when I decrease the voltage, as you can see, the waveform is goes above, and the voltage supply is somewhere around 2. But there is a catch. This waveform is cannot cross 3.6 volt breakdown voltage, because the Zener diode breakdown voltage of this Zener diode is 3.6 volt. So, and another thing is, I am giving a triangular wave, and as you can see, this is the output wave, but it is not exact a triangular wave because it is slightly curvy nature. So we can't say this is exact a triangular wave. Why it is? It is because this is nearest to the breakdown voltage, so that's why it slightly bends. So that is the reason why this is not exact a triangular wave. So and it can't go above 3.6 volt. So this is part 2 of point 1 of this experiment, and let's change the circuit and jump to the another part. Now this is a point 2 of this experiment. Now I'm nothing changes, just in the series I added a another Zener diode, the same breakdown voltage, that is 3.6. Now the breakdown voltage of this circuit, this both Zener diode is something around something around 7.2 volt. So I have a power supply that is 5 volt, and it can't go above 5 volt. But as you can see in the Pixel Pulse software, the waveform is exact triangular, and it is somewhere around 4.6 or something 4.7, and the RL is I set to the somewhere around 0. Yeah, now RL is 0, and as you can see in the Pixel Pulse software, it is somewhere around 4.7 volt across from 4.7 volt to somewhere around 2.7. So this is the waveform I am getting in the output when I connected 2 Zener diode in the series in this circuit. Let's jump to the next part. Now this is the another part. In this part, I just replace a 220 ohm resistor with 470 ohm. In the doc file, it given 500 ohm resistor in series, but I don't have 500 ohm, so I just use a 470 ohm resistor in series. So as you can see in the Pixel Pulse software, there is no changes. Just the change is I am giving an exact square wave, but the output wave is more curvy in the nature, and the breakdown voltage is in I was seeing it decreases somewhere around 3.49 something. So I just see the slight changes when I increase the resistor value in the series, and I set this RL is nearly to the 0. So that is the part 2 of this experiment, and thank you.